Naturally, we can't show you all of the material that you'll cover in one of our full 40-hour boot camp classes, so these video lessons are meant to be a preview, not a substitute. One important thing that we won't be able to show you is just how mentally active you'll be throughout the entire course. Actually, you'll start working on your first hands-on exercise within the first 10 minutes of the class on Monday morning, copying this simple walkthrough program into your PLC processor. If you're a raw beginner, we'll give you any over-the-shoulder coaching you need to get started. If you're a more experienced student, you'll get an extra project to work on if you finish putting this little program in early. Either way, we'll cover everything you see here, timers, counters, and the rest, in detail before lunchtime on Monday morning. It's amazing how much you can learn and retain when you skip the boring lectures and cover everything step by step using realistic hands-on exercises. Take a look at the top 2 rungs of the walkthrough program. The next few videos in this series will concentrate on these. When you go through the class, you'll wire up your own individual student workstation for your experiments. For our video lessons, we'll use this same simple light box that we introduced earlier. If you want to work through some of these exercises at home, you can use a micrologic system or a SLC 500 or a PLC 5 system like the one we're using today. Remember that the newer ControlLogix platform uses a different scan sequence, so it might not give exactly the same results as our video lessons. Even if you're signing up for our ControlLogix bootcamp, it's still a good idea to start with the material we'll be covering here. Here's a screenshot of the top 2 rungs of the walkthrough program, controlling a quick demonstration of the light box. The first rung uses switch A to control lamp E. So when we turn switch A on, lamp E comes on. When we turn switch A off, lamp E goes off. The second rung gives the opposite action to lamp F. So when we turn switch A on, lamp F goes off. And when switch A is off, lamp F comes on. It looks simple, but even our more experienced students can usually learn a few things from this little exercise. Here's just a quick preview of some of the behind-the-scenes details that we'll work our way through as we cover the top 2 rungs. Yes, you can start at the raw beginner level in our PLC bootcamp class. Many students do, but you should expect to go much deeper than the beginner level of just how PLCs work. That's because we focus on all of the step-by-step skills you'll need to systematically troubleshoot a PLC control system when it doesn't work. Many other PLC training programs never cover problem-solving and troubleshooting skills. Our classes concentrate on these critical areas. Experienced PLC technicians will tell you that most of their troubleshooting problems are concerned with the devices and the wiring out in the field and not with the ladder logic program. Let's try to get a head start on those wiring types of problems by seeing how our simple light box is wired up. We'll start with an input device, switch A. In most micrologic systems, the input wiring is connected to a row of screws along the top of the unit. In a SLC 500 system, it's usually connected to an input module located in the chassis. The same old plug-in input module idea applies to the larger PLC 5 system that we're using in this series of videos. But regardless of where the inputs are physically connected to the hardware, our PLC bootcamp approach always shows the inputs at the far left side of our whiteboard drawing. Even at this early stage, we're already developing a systematic left-to-right flow of the signals through the PLC. So here's a sketch of the basic input module. Let's wire up switch A. We'll start with a 120-volt AC power source. If you're following along with your own hardware at home, make sure that the power source you're using matches up with the specifications of your PLC's inputs. Next, we'll run a wire from the power source down through switch A and continue on to a terminal screw on the input module. Finally, we'll need a return path for the current flow, so we'll make a neutral connection to another screw located at the bottom of our sketch. This information will come in handy when you design and connect your own hands-on wiring exercises in Tuesday's bootcamp class. Now if we go to switch A and turn it on, we'll have a continuous path of current flowing through the internal components of the module. Take a quick look, because to keep things simple, we won't show the internal components of the input module in most of our sketches from now on, but you'll remember that they're there. Now let's connect an output. We'll use lamp E on the light box for an example. In most micrologic systems, the output wiring is connected to a row of screws along the bottom of the unit. In a SLC 500 system, it's usually connected to an output module located in the chassis. Many people call a module a card, and here's an output card, or a module, being used for the larger PLC 5 system that we're working with today. But regardless of where the outputs are physically connected to the hardware, we'll always show the outputs at the far right side of our whiteboard drawing. Here again, we're already looking forward to our future troubleshooting exercises by setting up a left-to-right flow of the signals through the PLC. So here's a sketch of a basic output module. Let's wire up lamp E. We'll start with a 120-volt AC power source and connect it to a terminal at the top of our output module. Since we're trying to focus on the PLC piece of the puzzle right now, we'll leave any fusing and disconnects for another lesson. And again, if you try this at home, make sure to use a power source that matches your PLC's outputs. Now inside the output module, we'll see a set of contacts. And let's pause right here for a second. This is a problem area where many people have misconceptions. The common misconception is that all PLC output modules have contacts, just like the ones we're showing here. Actually, many output modules use solid-state devices like this triac. We'll get the voltmeter out later in the course and cover the differences, especially the leakage current that continues to flow through the solid-state triac even when it's turned off. There can be some serious shock hazards involved in this particular topic. Still, a lot of PLC output modules do use relay-type contacts, and it's easier to see what's going on in the circuit using this type of schematic symbol. So that's the way we'll draw it on the whiteboard. Now let's move along and connect up lamp E in the field. And of course, we'll need a return path for the current flow, so we'll make a neutral connection at the bottom of the sketch. Now let's go back to the contacts. At this point, they're still open, so let's mark lamp E as off. If we could somehow close those contacts, then lamp E would come on, and this is the path that the electrical current would follow. Let's turn the contacts off again, and we'll talk about how we do that as these lessons continue. Naturally, lamp E goes off, and we're ready for a quick review. So far, we have our input module at the left side of the whiteboard with switch A connected and ready to go. We have our output module at the right side, and lamp E is wired and ready. And we're already developing a systematic left-to-right flow of the signals through the PLC. In our next lesson, we'll introduce the PLC processor, the brains of the operation, and see how it fits into the picture. Remember that these videos are intended to be just a quick preview of some of the material that you'll cover in one of our PLC bootcamp classes. If you'd like more detail on how each 5-day course starts at the raw beginner level and then goes hands-on all the way through processing analog signals, just check out the full course descriptions on our website.